me another one right away, because you know the conjugate needs to be there. All right, so complex zeros always come in conjugate pairs. A plus bi and a minus bi. So what that allows you to do is, if you have some polynomial, let's say we're going the other direction now. I'm going to start with the equation, and we're going to see if we can pull out what the roots are. So if like that other one, I told you x minus 5 is a root, just going to give you that one to start with, okay? So if the one I just give you is a complex number, then you can actually say, oh, all right, I got another one. I got a second one I can use too. So let's see, what's one I can give you? Find one I can steal that works well here. Okay. Okay, so we're going to look at that one. And let's say, for this particular one, x equals I is a root. So there's your freebie. We know I is a root. So if I know that I is a root, or technically 0 plus I is a root, what's another root that must be with this equation as well? Yeah. So the conjugate of that, 0 minus I, must also be a root. Because of that complex conjugate zeros idea. All right. So this will be the last thing that we do today. So what we're going to do then is we're going to start the process of, if I know a complex root, how do I then go through synthetic division like we did with real numbers and find the rest of my zeros? Okay? The process is exactly the same, except for when you have imaginary numbers in your synthetic division, you have to be careful about the properties of those and using them the right way. And we'll come across some of those as we go here. So, I know that x equals I is a root. So, just like we did before, instead of a number or a real number going in the box, now I'm going to put I in the box. Take all the coefficients off my polynomial. and work through a synthetic division. Now with these, if you haven't yet, you might want to do this before we get started, but you're going to want to kind of space these out a little bit more than you normally do, because we're going to have some complex numbers in there. All right, so first things first, bring down the 1. I times 1. Just I. Okay, then what do we do down the columns? We have to add them together, so this is 3 plus I. Like that. Okay, like I said, you're going to need a little more space. And then, what do we do? Times by I. Okay, I'm going to go to the board here, and I'm going to do that. You might be able to start doing this in your head in a little bit, but this first one, I'm going to write them over here on the board so you can see it written out a little bit. But if I do I multiplied by 3 plus I get 3I plus I squared. Right? If I distribute the I into there. But what is I squared? Negative 1. So what I actually have is negative 1 plus 3I. Okay? Now if you need to go off into the margin of your paper and write that out every time, that's totally fine. Please make sure you're doing it the right way. But after a while, you might be able to start doing that in your head. So negative 1 plus 3I, though, is what we get when we multiply those together. Okay, so then, again, add down the column. Okay, like terms, what do we get? Mm-hmm. And then multiply I times that. So if I distribute that I, I've got negative 4I plus 3I squared. And again, I squared is negative 1, so it's negative 3 minus 4I. Okay, add up that column. What do I got? I think I heard somebody say negative 4I. That's right. And then if we multiply again, I times negative 4I is negative 4I squared, which is positive 4. So even though my answer is a bunch of complex numbers, it did what it was supposed to do, though, right? Remainder of 0. Okay? That's what we're supposed to get when we have a root. Remainder of 0. And even though it was complex, that did do that. Okay. So, I've got that one out. And this would be the coefficients of my polynomial. Please don't write it out with those coefficients. It's going to look really nasty. Because I got one more synthetic division to do right away, right? What's the other root I know that I have? Negative I. So I'm going to repeat the process with this using negative I. And this one, if you've done the first one correctly, this one turns out way easier every time. It goes so much faster. But we got to copy these coefficients down onto this one. Okay, bring down the 1. Negative I times 1. Negative I. Add them up. 3. Negative I times 3. Add them up. Negative 4. Negative I times negative 4. 4I. And like we're supposed to get, remainder is 0. And if you've done your math correct, the answer to this one should have no more i's. Because we've taken care of all of our imaginary roots, right? We took care of both of those conjugates. They're both gone. So what's left? We should be looking for some real zeros now. And what we have is x squared plus 3x minus 4. which is factorable. I can find the rest of those roots by factoring that thing. What adds to 3 but multiplies to negative 4? Okay, so I've got my other two roots. X equals 4. I'm sorry, negative 4. And x equals positive 1. Okay? So, negative 4, 1, I, negative I. How many roots do I have? 4. What's the degree? 4. Degree is 4. Should have 4 complex roots. Got them. All 4 of them. Okay? Tomorrow in class, you're going to be doing mostly this kind of stuff, practicing this. Okay? Using those complex roots to get more complex roots, and then to get the rest using your synthetic divisions. All right, we'll stop there for today.